Okay, so we are looking at first order linear ordinary differential equations. Actually, these are, yes, first order linear ordinary differential equations. And the way we are solving them is we find an integration factor mu, and then when we find the integration factor mu, our solution to the differential equation, that is the solution of y prime plus p of xy equals q of x is this solution right here. So we were in the middle of a problem. I think we were doing problem number 2. And we had stated that, right, here we were at problem number 2. And we said that this was originally not in standard form. We divided by x and put it in standard form. And then after we did that, we were able to follow our algorithm. So the first thing says find or identify p of x and q of x, that we did. Then we took the integral of p of x, which gave us 2 times the log of x, which gave us the log of x squared using logarithm properties. Then we found v, our integration factor. So v, as we said, this is our integration factor. Okay, so after we find the integration factor v, then in step 4, we must compute the integral of q of x times v of x dx. Okay, so that gives us the integral q of x is 1 over x minus 1 over x squared. V of x was x squared dx. This is the integral. When we multiply by x squared, we simply get x minus 1 dx. So this becomes 1/2 x squared minus x. And as I said, don't forget your constant. So then our solution is y of x is the quotient of our integral of q of x, v of x dx, plus our constant divided by v of x. So the answer to this problem is y of x is equal to 1/2 x squared minus x plus a constant divided by x squared. And unless they give you an initial condition, which this problem did not, we do know that x is greater than 0. We need that at least for the beginning of the problem, and we also need it for the actual solution. Okay, are there any questions about this? So this is 1/2 minus 1 over x plus c over x squared. All right, so that is the solution to our problem. Okay, questions? All righty, let's go.
Can you go back up to the 4th step for a second, please?
I certainly can. You mean here?
Yes.
Okay, there you are.
Thank you. I just need to take a picture.
You're welcome. Okay. Okay, so where are we? Let's see. Oh, we are not that far. We are on number 3. All right, so here's problem number 3. And I need somebody to start me off on this problem. Give me some information about this problem. Hello.
Is the problem not a standard form?
Okay, so this problem is not in standard form. Okay, so how do we put it into standard form?
Which you divide by x on from left to right.
Okay, so do you mean divide by x?
Yes, ma'am.
Okay, so when we divide by x, we get y prime minus 1 over x. Y is equal to 2. The x's are going to divide out and we get the natural log of x, and we know we can do that because x is positive. Okay, so now it is in standard form. So what do we do in step 1? Step 1.
Would it be to find p of x, which would be would it be neutral x?
What's p of x?
Oh, sorry, I'm sorry about the noise. Would it be natural log of x? Or,
Okay, so that's going to be our q
oh, sorry.
Q of x is 2 times the natural log of x. Okay, so what is our p of x?
Isn't our p of
1
x 1 over x?
Okay, but it is negative because it is negative here. Remember, it's plus p of x. So therefore, that whole thing has to be p of x. So it is negative. Okay, any questions? Okay, that's the first step. What's the second step? What do we do in the second step? Second step. We need to go back. Okay.
So find the integral of p of x, which
Okay. So we have the integral of p of x. So that is the integral of negative 1 over x dx. Okay, so how do I integrate that?
would it be negative natural log of absolute value of x?
Okay, so it's negative natural log of the absolute value of x. Remember, I said here we don't need the constant. Okay, so at this step, no constant is needed. And we also know that x is positive, so we don't need the absolute value. So therefore, we get this is equal to the negative natural log of x, but let's use logarithm properties. So if I use logarithm properties, I get the log of x to the negative 1. Okay, any questions about that? Okay. All righty, so
Well,
then,
Dr. Watt?
yes.
Oh, sorry. I didn't catch what you meant by when it comes to the absolute value.
Okay, so remember, we can't take the log of a negative number, which is why when you do the integral of 1 over x, you get the log of the absolute value. But we tell you here in the problem that x is always positive. So therefore, I need to keep the absolute value because I know that I don't have to make a positive number positive because that's inherently its property.
Okay, thank you.
You're welcome. Okay, so that's P of X. Step 3. So our V of X is e to that integral of whatever we found. And for us, that's e to the natural log of x to the -1. But here we have our inverse functions. E and natural log are inverse functions, the exponential. So we get x to the -1, but that's simply just 1 over x. So that is our V. Okay, step 4. All right, step 4 can be the most challenging part of this problem. So we need to compute the integral of Q of X, the integral of Q of X times V of X dx. And that is the integral. Q of X, we said, is 2 times the natural log of X. And then V of X is 1 over X dx. Okay, so that's what we have. All right, how do I integrate that? What method am I going to use for integration? Like I said, step 4 usually is the most difficult or challenging part of the problem.
Would you use the multiplicative rule of integration?
I'm sorry, what did you say?
Sorry, the multiplicative rule of integration, where you would take the would it be the derivative of the first, derivative of the second, and then
Oh, we
compute?
cannot do that. So they're actually, that only works for differentiation. It does not work for integration. Okay, good guess. I can understand why you would want to do that, but that's not how we can solve this part of the problem. Okay, so we need to do something that's actually a lot simpler than that. I see a function and I see its derivative sitting right next to it. So this is prime for what technique?
Maybe use substitution.
Use substitution. Okay, so what is U going to be?
Would you be natural log of
X, okay, and du?
1 over
X dx. So we're looking pretty good here. I can pull the 2 out and I get the integral. Natural log is just u, and 1 over x dx. Oh, I'm sorry, I wrote du. 1 over x dx, we can completely substitute out as du. Okay. So now we're going to integrate this. So we're going to get 2, and then we're going to get u squared over 2 plus a constant. Now here's where we have to have the constant. So this is u squared plus a constant. So my answer becomes the log of x quantity squared plus c. Okay, so now we're down to the end. 5 y of x looks like this integral of q of x, v of x dx. And like I said, we need the constant, and that is divided by the whole thing, v of x. So that gives us the natural log of x squared plus a constant, and v of x, well, I think that was a rational function. That was 1 over x. That's correct. 1 over x. So therefore, my solution y of x says take the x and multiply it by the natural log of x, quantity squared plus a constant, and we are done. And again, they did not give us an initial condition, so we cannot solve for the constant. Okay. All righty. So I'm going to give you another problem. This is number 4. This problem actually has an initial condition. All right, so I tell you that the solution goes through the point 0, -6. So the curve, whatever the solution to the curve is, it goes through 0, -6. Okay, so I'm going to pause the recording for a minute while I take roll, and you are going to work on steps 1 through 5 of this problem. All right, so we're coming back off the break. Somebody help me, help me. Okay, let's say Dr. Lott is drowning. And I need you to answer these problems to save me. Who wants to save me? Who's gonna try to save me? Anybody? Wow.
I could give it a shot. I'm not too
Okay.
sure if I did it correctly.
Okay, what you
Um,
got, Caesar?
All right, so well, first, basically we're putting the y's on one side and the x to the other, correct?
Okay, that's the separable differential equation. This one is the first order differential equation in standard form. So I need it in the form dy dx plus p of x y is equal to q of x. So my first question to you is it in standard form?
Yes.
Yes. Okay, so what's p of x?
P of x should be x.
Good. And what's q of x?
Q of x is also x.
Also x. Okay. First hurdle done. All right, so good. I'm backstroking a little bit. Maybe I'm gonna make it to the edge of the pool. Okay, who's anybody? Caesar, you can keep going.
All right, and the next one is the integral of px dx, correct?
All right. And
And
what?
that should be, since it's x dx, that would be x squared over 2.
Okay. Remember we said we don't have to worry about a constant. No constant here. Okay, good. All right, so now next step is to find V. Well, that's just e to that integral.
That'd be e to the x, and is that like 1?
You got to include the half.
Oh, sorry.
Yep, e to the 1/2 x squared. Okay, looking good to me. What do I do next?
The integral of qx vx dx.
Integral of q of x, v of x, dx. So that's the integral. Q is x, and then I'm going to get e to the 1/2 x squared dx. Okay, how do I integrate this? Again, I always ask, first and foremost, do you see a function and its derivative or a multiple of its derivative anywhere nearby?
Yes.
Yes. Okay, so what do you see?
The x and the x squared over 2.
Okay, so let's let u be 1/2 x squared. And then du is just x dx. Okay, so now we have a perfect x dx. And then we have e to the u. Okay, so this is a nice integral. It's the integral of e to the u du. And e to the u, it integrates and becomes what?
U.
E to the u. Here we need the constant, so it's important. All right, so this is e, and then u was 1/2 x squared plus a constant. Okay, so far so good. All right, last step, Caesar. I think I'm going to actually make it to the other end of the pool. We're getting close.
Last this yx equals to the integral of qx vx dx plus c over vx.
V. Okay, so for the numerator, we get e to the 1/2 x squared plus my constant c. And I'm going to divide by v. And let's see, what was v? V was
E to the x squared,
e
half
to the
x squared.
1/2 x squared. Good. E to the 1/2 x squared. Okay, so that's looking pretty good. All right. We could even make it look nicer. We could say y of x, e to the 1/2 x squared over e to the 1/2 x squared is just 1 plus c e to the negative 1/2 x squared. So we can do it like that as well. So either one of these works as the solution to my problem. All right, so I would take either one of those. Am I done?
No,
No. So what do I still have to do?
because we were given y0 equals -6, so we plug in
Okay.
these 0 for x.
Good. So we're given y of 0 is equal to -6 is given. All right, so Caesar says put in x equals 0. Okay. And when we do that, we get -6 is equal to 1 plus c. So c is equal to -7. So now we have y of x is equal to 1 minus 7 e to the negative 1/2 x squared. And now we have a final solution to the problem, a complete solution to the problem. Any questions? Any questions? Okay, so we have two more problems to do, but I decided to, I know you guys like to take a break in the middle of class. So we are going to take a break and have a new share as soon as I can find it. Oh, okay, wait a minute. I gotta go back. Let's see. Oh, there it is. Okay. Okay, get your tablets and phones ready. We're going to do Kahoot. It is loading the game pin. There we go. 792-6448. You can either scan the QR code. Please put your name in so that I know who you are. No crazy nicknames. I won't be able to go back and give you any extra credit for playing. Okay, I have one player. Max, Peyton, Alexis, Dominique. It is $12 of you on here, so. All right, so true or false questions are only 10 seconds. Short answer questions are 20 seconds. The last question is 2 minutes.
I'm having trouble with the Kahoot app,
Okay,
trying to reinstall it right now.
okay,
Again.
All right, I'm still missing 4 people. I know Caesar's getting it together. Okay, Jadeja, thank you. Anyone else? Oh, I lost somebody. Oh, I lost another person. Okay, if you drop out, please come back in. Caesar, where are you? You almost done?
It's still loading, just very slowly for some reason.
I'm still missing 4 people. Destiny, oh, she's on there. Chara, Victor, Malcolm's on there. Caleb's on there. Mikhail, I'm missing Mikhail. I'm also missing. Okay, Caesar, I'm going to go ahead and start. When you get it, just jump in. There you go. Okay, here we go. Euler's method is used to solve a separable differential equation, first order differential equations, both or neither. Okay, we can actually solve both of them. All right. We say an improper integral diverges when the limit approaches 0, the limit approaches positive or negative infinity, the limit is equal to L, or none of the above. Okay. Next. A first order differential equation in standard form is, okay, so please look at A, B, C, and D, or red, blue, yellow, and green, and make your selection. Wow, okay. We need to work on that a little bit. Which of these numbers does not appear in Simpson's rule? Okay, number 1 does not appear in Simpson's rule. True or false? The estimated error for the trapezoidal rule is smaller than the estimated error for the midpoint rule. Okay, the error for the midpoint rule is smaller than the trapezoidal rule. The midpoint rule is used to estimate the volume of revolution of a curve f of x, the area under the curve of a function f of x, the surface area of revolution of a curve of f of x, or all of the above. Okay, good, good, not too bad. True or false? The comparison theorem is used to determine whether a definite integral is convergent. And that should not say definite integral. That should say improper integral. My apologies. Okay, good. I apologize. That should say improper integral. Okay, you guys are smoking. True or false? An ordinary differential equation contains an independent variable x and a dependent variable y and derivatives of x and y. Oh my goodness. Whoa, okay. We need to go over that definition again. All right, last one. In a first order differential equation, y of x is equal to the integral, well, you can see them. Okay. And the last one. The last one you have 2 minutes for. The solution to the differential equation dy dx is equal to x over y, where y at 0 is 1, is a hyperbola, is undefined, is a circle of radius 1, or none of the above. So you have 2 minutes to solve that. Okay, you have 30 seconds. All right, the answers are pouring in. Fifteen seconds. Okay. All right, let's see the scoreboard. Destiny. Max. Peyton, all right. Okay, runners up are Malcolm and Jadeja. Okay. Let me stop this from playing. Okay. Any questions, anybody? All right. All right, so we're going to do an application of our first order linear differential equations. Some of these can actually be rather difficult. I have chosen to do a fairly reasonable one that's not too difficult. Okay, so I want to do a mixture problem. Okay, so here's the problem. A tank contains 100 gallons of a 10% salt solution. A solution containing 1 pound per gallon of sodium chloride runs into the tank at a rate of 1 gallon per minute, and the well-stirred mixture is pumped out of the tank at a rate of 1 gallon per minute. How long will it take before the mixture is at a concentration of 75%? Okay. Now, I know this sounds a little hairy scary, but it's actually not too bad. So the rule that we're going to use is the rate of change of the amount of substance in a container is going to be the rate in times the concentration in and the rate out times the concentration out. Okay, so let's let X, Y, we can use Y. Y is going to be the amount of salt in the tank. At some time t. And the rate of change of the amount of that substance is dy dt. So dy dt, that is the rate of change of the amount of salt. And its units are Y, which is the amount of salt, so that's pounds. And the rate of change with respect to time, so this is seconds. So its units is pounds per second. Okay, so the rate of change of the amount of salt is going to be the amount of pounds of salt that are in there that change per every second. Okay, so those are the units. Okay, so now let's look at the rate in. So the rate in well, the rate in is 1 pound per gallon. No, the rate in is 1 gallon per minute. Oh, I think we're using minutes, not seconds. Okay. And then the concentration coming in is 1 pound per gallon. So that's the rate in, the concentration in. So that is 1 pound. Uh-oh, how in the world? Per gallon. So now if I take the rate in times the concentration in, that's going to give me 1 gallon per minute times 1 pound per gallon. And as you can see, gallon units are going to divide out. And that's going to give me 1 pound per minute. Okay, 1 pound per minute. So notice, same units. Okay. Then what's the rate out? Well, the rate out is 1 gallon per minute. And what's the concentration out? Well, the concentration is always the number of pounds of substance, which for us is Y. We don't know. Y is the amount. Remember, Y is the amount of salt in the tank at time T. So when it goes out, we don't know how much is in there. That's what we're trying to figure out. So that's just Y. And the amount of fluid, well, if it's coming in and going out at the same rate, it's always going to be 100 gallons of solution in the tank. So this is going to be Y over 100. Okay, so again, we're going to take the rate out times the concentration out. And that's going to equal the rate out, which is 1 gallon per minute. And the concentration out is Y pounds per 100 gallons. And once again, our units, our gallons are going to divide out. Uh-oh, not the 100 gallons. And so now I'm going to get Y over 100 pounds per minute. Again, same units. Okay. So now I'm going to go back to my original question, well, my original statement, which is the rate of change of the amount of substance in the container, that's dy dt, is going to equal the rate in times the concentration in minus the rate out times the concentration out. So the rate of change, so that's going to give me dy dt is going to equal the rate in times the concentration in. We said that was 1 pound minus the rate out times the concentration out, which is y over 100. And so when I look at that, I can rewrite that as dy dt plus 1 over 100y is equal to 1. Okay, so that is a first order linear differential equation in standard form. Okay, so this for us right here is in standard form. Okay, now I need an initial condition. So let's go back and look at our problem again. So the problem says the tank contains 100 gallons of 10% concentrate solution. Okay. So if it's 10% concentration, so initially 10% concentration. Remember the concentration is equal to the number of pounds of salt divided by the total amount of fluid, or the total mixture amount. And they're telling me that is 10%. So can somebody tell me how many pounds of salt there are to start? Hello? So we have 100 gallons. The only way I can get 10% is if I have 10 pounds of salt. So that implies that y of 0 is 10. So here is my differential equation, and here is my initial condition. Any questions? Okay, so now it is your job to solve dy dt plus 1 over 100y is equal to 1, subject to y of 0 is 10. So what do? I have 4 steps to solve this. What do?
Get px qx.
Okay, 1. So actually, we're going to use t for this problem. Remember, I told you sometimes a lot of times we'll use t when it's time. So P of t is equal to what?
1/100.
Okay. And then Q of t is
1.
1. Okay. All right, 2. Integral of P of t dt. This is an easy one. Integral of 1/100 dt just becomes 1/100 t. Again, no constant needed. 3. V of t is e to the integral of P of t dt. So that's e to the 1/100 t. Okay. 4. Integral of Q of t V of t dt. So that's the integral. Well, Q of t is 1, so that's easy. That's just e to 1/100 t dt. And we know that the integral of e to the k t dt is equal to what? What happens to that constant? We multiply by it, divide by it, throw it away. This is 1/k e to the kt constant. So this is going to be 1/100. So that's going to be 100 e to the 1/100 t plus a constant. So y, step 5, y of t is going to take what we just found, which is 100 e to the 1/100 t plus a constant, and divide by v, which is e to the 1/100 t. So that's going to give me 100 plus a constant times e to the negative 1/100 times t. Okay, any questions? So now, are we done?
Solve for y.
Okay, we have to figure out this constant. So we have y of t is equal to 100 plus c e to the negative 1/100 times t. And we said y of 0 was 10. So it initially only started out with 10%. So that was only 10 pounds of salt. So therefore, we get 110, that is y of 0, but that's 100 plus c e to the 0. So therefore, I get 10 is equal to 100 plus c. So c is equal to negative 90. Why does that feel weird? Let me go back. That feels weird. There's something about that I don't like, but I haven't figured it out yet. Okay. That's right. That's right. So therefore, y of t is 100 minus 90 e to the negative 1 over 100 t. Yep, that makes sense. Okay, so that's the amount that's in there at any given time t. That's the amount of salt. So we now have found the formula that tells us the amount of salt at any time t. So now the question asked us, how long will it take before the mixture is at a concentration of 75%? Okay, so how do I solve that?
Would it be rate in times concentration in minus rate out times concentration out?
Okay, actually, we don't have to do that much work anymore. If the mixture is 75% at some t, that implies that since it's still only 100 gallons of mixture, that means there must be 75 pounds of salt in the 100 gallons of mixture. So we need 75 to be 100 minus 90 e to the negative 1 over 100 t. How do I solve that? We did this with some other problems. How do I solve this? Using my formula. How do I solve it? Okay, y'all were scaring me again. Subtract 100 from both sides. Is equal to minus negative 90 e to the negative 1 over 100 t. So now I get 25 over 90 is equal to e to the negative 1 over 100 t. Now I want to get t out the exponent. So what am I going to do to both sides? How do I get t out the exponent?
Would it be by taking the natural log?
Okay. So I'm
Yeah, I
going
was
to,
just about to say the same thing.
yeah, well, that's right. The natural log of 25 over 90 is equal to the natural log of e. Oh, there we go again. Those inverse functions, we like it. So the log of e just gives us the exponent. So we get the natural log of 25 over 90 is equal to negative 1 over 100 t. So t then becomes 100 negative 100 times the natural log of 25 over 90. Now, if you're on a test, that's your answer. Okay? This is a test answer. That's what I would look for. Okay? A homework answer, well, they're going to want you to be a little bit more specific. I'm going to get minus 100 times the natural log of 25 over 90. All righty. 128.09. What are the units? What are the units?
Pounds per gallon.
It's T. T was in,
Was it minutes?
T is in minutes, okay. So if I take that 128, this big, huge number, which on the homework, it would ask you to round it to the nearest number. So you would say 128. But if I take this and divide by 60, that gives me a little over 2 hours.
You good, bro? Yeah. Move on that stat test, bro.
I asked her one question. She's like, no, I can't. I've been sitting there like,
Okay, any questions about this problem? Okay, they can make these problems much more difficult. That is, the rate in may not equal the rate out, which means the tank could fill up or the tank could run out of water. Okay, I'm not going to hold you responsible for those kind of problems on the exam. So why am I going backwards? I want to go here. I want you to solve this. We have a few more minutes and I don't want to start another section. So I have one more problem for you to solve and that'll take us on out. All right. Here we go. Last problem. How do we solve it? Hello.
Would you divide by x first?
Okay, so I'm going to get dy dx going to equal the cosine of x over x squared minus 2 over x times y. X is greater than 0, so I'm okay with that. What comes next? Caesar, the only one paying attention today. I think Mikhail might have chimed in a little bit.
You have to subtract the 2 over xy or 2y over x.
For what?
I'm sorry,
Okay, yeah, we want to add that to the other side. You are right. Two over x, y is equal to cosine of x over x squared. Okay, good. All right, so now we can figure out what p of x and q of x are. Malcolm, what are they? P of X, Malcolm.
P of X would be, would it be 2 over X?
2 over X, awesome. Q of X is going to be,
Cosine X over X squared.
awesome. Okay, so that's step 1. Step 2, integrate P of X. That's the integral of 2 over X dx. I think we did this one already. It's 2 times the integral of 1 over X dx. Yes, we did this one. 2 times the natural log of X. Don't have to worry about absolute value because X is positive. And I wrote this as the natural log of X squared. Okay. 3, V of X. What is V of X? Compute it and give me a final answer for V of X.
E to the natural log of X squared.
And what is that reduced to?
X squared.
Good. Okay. 4, the integral of Q of X and V of X dx. Q of X was the cosine of X divided by X squared. V of X is X squared dx. Oh man, this is an easy one. This is a perfect test question. This is the integral of the cosine of X dx. And what is that? Antiderivative of cosine of X.
Sine of X.
Okay. Plus a constant. All right, so 5 y of X says take that, which is the sine of X plus a constant. And then we are going to divide by V, which is X squared. And I don't think I gave you an initial condition. Nope. So we are done. Okay, does everybody see how these problems are? That is exactly what kind of problems you are going to have on the exam. Now, if you have something that looks like, here's one for you. Dy dx. Plus the tangent of xy is equal to secant of x. What's P of x?
Tangent X.
Tangent x. Q of x.
Secant.
Secant. Okay, so when you do the integral of P of x dx, you're being asked to find the integral of the tangent of x. This is the one that was on the Kahoot. Looks something like this. Now, if you have to find the integral of the tangent of x, you need to remember that is the log of the absolute value of the secant of x. And then we don't need the constant. So I would have to tell you that x is between, I want the secant to be positive. So maybe if I said x is between 0 and pi over 2. Okay. So therefore, when you go ahead to get to your v of x, which is e to the integral of p of x dx, that is e to the natural log of the secant of x, which just becomes the secant of x. How's that? So even though p of x looks difficult, okay, p of x can look difficult. If you remember that the integral of p of x is simply the log, then when you do e to the log, you get a nice function. So now you have to do the integral of q of x, v of x dx. And that's the integral of the secant of x times the secant of x dx. And now we're talking the integral of secant squared, and that's just tangent plus c. So sometimes a difficult problem may, sometimes an easy problem may look difficult if you get trapped in your head and you start worrying about it. But if you just take the time to plow through it, you will see it's not difficult. Okay, so finish this problem. And I will see you guys either tomorrow at office hours, or this afternoon at office hours, or I will see you Thursday.
When is the test, the exam?
Next Thursday.
Next Thursday. Okay, thank you.
Yes.